This lecture is about the future of web search. In this lecture, we're going to talk about some possible future trends of web search and intelligent information retrieval systems in general. In order to further improve the accuracy of a search engine, it's important to consider special cases of information need. So one particular trend could be to have more and more specialized and customized search engines, and they can be called vertical search engines. So these vertical search engines can be expected to be more effective than the current general search engines because they could assume that the users are a special group of users that might have a common information need, and then the search engine can be customized to serve such users. And because of the customization, it's also possible to do personalization. So the search can be personalized because we have a better understanding of the users. Because of the restriction to the domain, we also have some advantage in handling the documents because we can have better understanding of documents. For example, particular words may not be ambiguous in such a domain, so we can bypass the problem of ambiguity. Another trend we can expect to see is the search engine will be able to learn over time. It's like a lifetime learning or lifelong learning. And this is, of course, very attractive because that means the search engine will self-improve itself. As more people are using it, search engine will become better and better. And this is already happening because search engines can learn from the implicit feedback. The more users use it, and the quality of the search results for the popular queries that are typed in by many users will likely become better. So this is another feature that we would see. The third trend might be the integration of multi-models of information access. So search, navigation, and recommendation or filtering might be combined to form a full-fledged information management system. And in the beginning of this course, we talked about the push versus pull. These are different modes of information access, but these modes can be combined. And similarly, in the pull mode, querying and browsing could also be combined. And in fact, we're doing that basically today with the current search engines. We are querying, sometimes browsing, clicking on links. Sometimes we've got some information recommended, although most of the cases, the information recommended is because of advertising. But in the future, you can imagine seamlessly integrate the system with multi-mode for information access, and that would be convenient for people. Another trend is that we might see systems that try to go beyond the search to support user tasks. After all, the reason why people want to search is to solve a problem or to make a decision or perform a task. For example, consumers might search for opinions about products in order to purchase a product, choose a good product to buy. So in this case, it would be beneficial to support the whole workflow of purchasing a product or choosing a product. In this area, actually, the current search engines already provide good support. For example, you can sometimes look at the reviews, and then if you want to buy it, and you can just click on the button to go to the shopping site to directly get it done. But it does not provide a good task support for many other tasks. For example, for researchers, you might want to find the relevant literature or cite the literature, and then there's not much support for finishing a task such as writing a paper. So in general, I think there are many opportunities to innovate. And so in the following few slides, I'll be talking a little bit more about some specific ideas or thoughts that hopefully can help you imagine new application possibilities. Some of them might be already relevant to what you are currently working on. In general, you can think about any intelligent system, especially intelligent information system, as being specified by these three nodes. And so if we connect these three into a triangle, then we'll be able to specify information system. And I call this data user service triangle. So basically, the three questions you ask would be who are you serving, and what kind of data you are managing, and what kind of service you provide. Right? This would help us basically specify your system. And there are many different ways to connect them. Depending on how you connect them, you will have a different kind of system. So let me give you some example. On the top, you can see different kinds of users. On the left side, you can see different types of data or information. And on the bottom, you can see different service functions. Now imagine we can connect all these in different ways. So for example, if we can connect everyone with web pages and to support search and browsing, what do you get? Well, that's web search, right? What if we connect the UIUC employees with organization documents or enterprise documents to support the search and browsing? Well, that's enterprise search. If you connect the scientists with literature information to provide all kinds of service, including search, browsing, or alert of new relevant documents, or mining, analyzing research trends, or provide task support or decision support. For example, we might be able to provide support for automatically generating related work section for a research paper, and this would be closer to task support. Right? So then we can imagine this would be a literature assistant. If we connect the online shoppers with blog articles or product reviews, then we can help these people to improve shopping experience. So we can provide, for example, data mining capabilities to analyze the reviews, to compare products, compare sentiment of products, and to provide a task support or decision support to help them choose what product to buy. Or we can connect customer service people with emails from the customers, and we can imagine a system that can provide analysis of these emails to find the major complaints of the customers. We can imagine a system could provide a task support by automatically generating a response to a customer email, and maybe intelligently attach also promotion message if appropriate. If you can detect that that's a positive message, not a complaint, and then you might take this opportunity to attach some promotion information. Whereas if it's a complaint, you might be able to automatically generate some generic response first and tell the customer that he or she can expect a detailed response later, etc. All these are trying to help people to improve the productivity. So this shows that the opportunities are really a lot. It's just only restricted by our imagination. So this picture shows the trend of the technology, and also it characterizes the intelligent information system in three angles. You can see in the center there is a triangle that connects keyword queries to search and bag of words representation. That means the current search engine basically provides search support to users and mostly model users based on keyword queries, and it sees the data through a bag of words representation. So it's a very simple approximation of the actual information in the documents. But that's what the current system does. It connects these three nodes in such a simple way, or it only provides a basic search function, and it doesn't really understand the user, and it doesn't really understand that much information in the documents. Now I showed some trends to push each node toward a more advanced function. So think about the user node here, right? So we can go beyond the keyword queries, look at the user search history, and then further model the user completely to understand the user's task environment, task need, context, or other information. Right? So this is pushing for personalization and complete user modeling. And this is a major direction in research in order to build intelligent information systems. On the document side, we can also see we can go beyond bag of words representation to have entity relation representation. This means we'll recognize people's names, their relations, locations, etc. And this is already feasible with today's natural language processing technique. And Google's recent initiative on the knowledge graph, if you have heard of it, is a good step toward this direction. And once we can get to that level of representation in a robust manner at large scale, it can enable the search engine to provide much better service. In the future, we would like to have knowledge representation where we can add perhaps inference rules, and then the search engine will become more intelligent. Okay, so this calls for large-scale semantic analysis, and perhaps this is more feasible for vertical search engines. It's easier to make progress in a particular domain. Now, on the service side, we see that we need to go beyond the search to support information access in general. Search is only one way to get access to information. We have recommender systems and push and pull, right? So different ways to get access to relevant information. But going beyond access, we also need to help people digest the information once the information is found. And this step has to do with analysis of information or data mining. We have to find the patterns or convert the text information into real knowledge that can be used in application or actionable knowledge that can be used for decision making. And furthermore, the knowledge will be used to help a user to improve productivity in finishing a task, for example, a decision-making task. Right? So this is a trend. And so basically in this dimension, we anticipate in the future intelligent information systems will provide intelligent and interactive task support. Now, I should also emphasize interactive here because it's important to optimize the combine the intelligence of the users and the system. So we can get some help from users in some natural way, and we don't have to assume the system has to do everything. When the human user and the machine can collaborate in an intelligent way, in an efficient way, then the combined intelligence will be high, and then in general we can minimize the user's overall effort in solving a problem. So this is the big picture of future intelligent information systems, and this hopefully can provide us some insights about how to make further innovations on top of what we can do today.